Hey everyone, welcome back to my study Pathshala. Today I'm going to present the chapter Real Numbers. Real numbers are the numbers that we use in our daily life. For example, 2, -5, 3 by 4, under root 2, pi, etc. In this chapter, we will find LCM, HCF, understand prime factorization, and understand rational and irrational numbers. So our first topic is Euclid division lemma. Euclid says if we divide one positive integer by another positive integer, we get dividend equals to divisor into quotient plus remainder. You can remember this equation from lower classes also when you did long division. In this, value which is written inside this symbol is called dividend. Value which we are dividing with is called divisor. What you are multiplying with is quotient, and whatever is left at the end is called remainder. So in this way you can remember this equation. The formula given by Euclid was A equals to BQ plus R, where R, which is our remainder, the value of R is always equal to or greater than 0, but it is always less than B, which is divisor. So B is divisor. A is dividend, Q is quotient, and R is remainder. For example, if we are dividing 17 by 5, we can write it as 17 equals to 5 into 3 plus 2. So here 17 is our dividend, 5 is our divisor, 3 is our quotient, and 2 is our remainder. The application of this Euclid division lemma is in finding HCF. Let's start with an example. Let's say we have to find HCF of 56 and 72. So what we are going to take is, we are going to take the bigger number first of all. So we are taking 72. We are going to multiply or divide it by 56. So 56 into 1 is 56. So remainder would be 16. So we have written it in Euclid division lemma form. In the next step, we'll take this divisor here and we'll divide by remainder. So 56 is taken here, we are dividing by 16. So 16 3s are 48, 8 is left, which is our remainder. So in next step, same would be moved forward. 16 will come here and we'll divide by 8. So 8 2s are 16, we get remainder as 0. So we have to continue these steps till we get 0 as the remainder. Once we've got 0 as the remainder, so whatever would be the divisor in that stage, that is our HCF. So HCF of 56 and 72 is 8. This topic is fundamental theorem of arithmetic. It says every composite number can be expressed as product of prime numbers in one unique way, except for the order of its factors. जैसे एक एग्जांपल लेते हैं, 60 को फैक्टर्स बनाते हैं. So 2 into 30 will give us 60, 2 into 15 will give us 30, 3 5s are 15, 5 1s are 5. So we get factors of 60 as 2 into 2 into 3 into 5. We can write it as 2 square into 3 into 5. Now we can arrange these factors in any way. We can write it as 3 into 2 square into 5, or we can write 5 into 3 into 2 square. So no matter how we multiply them, the prime factors will always remain the same. So this is what the fundamental theorem of arithmetic says. So today we are going to find HCF and LCM with the help of fundamental theorem of arithmetic. So in case we have to find the HCF, we have to take the smallest powers of common prime factors. So we have to check which all the prime factors are common and take their smallest power. In case of LCM, we have to take the greatest powers of all the prime factors. So we have to take all the prime factors and take their greatest powers. So let's understand this with help of an example. Let's take first example in which we are taking three numbers, 6, 72 and 122. So we are going to find HCF and LCM of these three numbers. So prime factors of 6 are 2 into 3. Prime factors of 72 are, you can see I have calculated it here, 2 into 36, 2 into 18, 2 9s are 18, 3 3s are 9, 3 1s are 3. So we've got 2 cube into 3 square. Similarly, we'll find prime factors of 120 as it would be 2 cube into 3 into 5. Now in case of finding HCF, we have to take common factors first of all. So let's see what is the common factor in all of them. As you can see, 2 is here, 2 is here, and 2 is here also. So 2 is the common factor in all of them. So we'll take the smallest power of 2. 2 raised to power 1, 2 raised to power 3, 2 raised to power 3. So smallest power is 2 raised to power 1. So we have taken 2 raised to power 1. Now similarly, we'll check for another common factor. 3 is here, 3 is here, 3 is here also. So 3 is also the common factor in all of them. So we'll take the smallest power of 3. We can see here 3 power is 1, here power of 3 is 2, again 3's power is 1. So the smallest power of 3 is 1. So we have taken 2 raised to power 1 into 3 raised to power 1. So 2 into 3, that gives you the HCF of 6. So similarly, we'll find LCM also. In case of LCM, we have to take the greatest power of all the prime factors. So let us see. We have got prime factors as 2, 3 and 5. So what is the highest power of 2 in all of these? So highest power of 2 is 2 raised to power 3. So we are taking 2 raised to power 3. What is the highest power of 3 in all of these? So highest power is this one, 3 square. So 3 square we are taking. And then 5 is alone in this one. So we'll take it as it is. So 5 is taken directly. So it becomes 2 cube, which is 8, 3 square, which is 9, and 5, that is 5. So 8 into 9 into 5 will give us 360. So the LCM of all these three numbers is 360. So friends, today we learned introduction of real numbers, Euclid division lemma, fundamental theorem of arithmetic, HCF and LCM by factorization method, or applying fundamental theorem of arithmetic. Thank you.